I'm going to pin this here. Okay, so what I'm going to do before we get into the details of all the algebra and fractions and whatnot, I'm going to show you how to set it up, because on the exam and the setup is most of the points. So see this first part right here. Let's see if I can pick the mouse here. Yeah, this part right here is pretty much the majority of the points. So if you can set this guy up, great. And there's different cases on how to set it up. So the solving is going to be the same, but the setup will vary depending on which case we have. Right? See how this one's set up a little bit differently. So what I'm going to do is go through all these cases and show you just the setup. And then I'm going to go back to the very first example and show you how to solve it. And then we're going to go through every single one, because the setup is the part that I need you to remember. The solving part will come eventually once you do it a few times, or once we do it. Let's see if this pen has any ink in it. 1 second. Okay, so we're going to start partial fractions. All right, let me stop sharing this here. You guys all have that open, right? So I don't need to see it. All right, so first example. All righty. Let me double check everything. I'm like paranoid. This is pre-cal, right? Yes. Okay. All right. Sorry. So here we go. Decompose 5 over x squared plus x minus 6. So the first step you got to do is factor the bottom. So you need to remember how to factor. Otherwise, it's gonna be a lot harder. So just looking at this bottom part, you can factor by trial and error, right? You guys remember how to factor these types of problems?
I do.
If you don't, you're gonna have to review this. So since there's no number in front of the x squared, you can go straight to the trial and error. We know it's going to factor this way. And what goes in here depends on the constant. So the factors of -6 that add up to +1, because there's an invisible 1 in front of the x. That's how we used to do it, right? So that's going to be, what is the factors going to be?
+1 minus 6.
+1 minus 6 that will not add up to 1 though. Is there
-2 plus 3.
Yeah, -2 plus 3. That's right. Okay, so we're going to start right here, assuming that it's already factored, and or it's not a big deal. But does anyone have questions on how to factor this before we move on to the actual problem? Is that okay?
No, I'm already lost. So I need to know exactly how you got -2 plus 3.
Yeah, okay, that's what I'm asking. So let's go over it. So the idea is you look at this number, right? And you think of the factors of 6. So you write down all the factors of 6. So I'm going to make a little list over here. So this is my -6, and I'm going to put all the factors down here. So -6 times 1, 6 times -1, 2 times -3, and -3 times 2. And over here, so you agree that these are all the possible ways to get -6, right? These are all the factors. Now, if we sum these factors, if you add them together, -6 plus 1 gives me a -5. 6 minus 1 gives me a +5. 2 minus 3 is a -1. Oops, I wrote the same thing twice. Check that out. That should be a minus here, positive there. So 3 minus 2 is a positive 1. So the one we want is this guy here. It's minus 2. Let me fix that. It looks ugly. This 3 times negative 2 is the one we want. And that's where we got these numbers from. Because these add up to a 1. Okay, so 3, negative 2. Okay, because it needs to add up to the 1 in front of the x. So this number, when factored, the factors must add up to this number here. And it's always going to be this way if the number in front of the x squared is a 1. Okay, so this is called trial and error factoring. Okay. Do you see where we got these numbers? If not, I will send you some factoring review stuff later. Okay. So let's go back to this part. Assuming that you guys are comfortable with the factoring, you end up here. And case 1 tells you, looking at your PDF, it says, if the factors are distinct, meaning they're not the same, then you do this approach. So basically what you do is write some number a over x minus 2, the first factor, plus b over x plus 3. So this is case 1 approach. That's the setup. That's all you got to do. Okay, so if they are unique factors, distinct factors, you write it this way. And that's it. And then we'll come back to it later when it's time to solve. But right now I want to focus on the approach, on how do you set it up. Okay.
So this
Any
is
questions so far?
This is breaking that down.
Mm-hmm. So the idea behind this is you can decompose a fraction into a sum of 2 separate fractions. So there's a theorem in the book that says any fraction that has a factor denominator can be broken down into a sum of both those factors. And there exists some a and b that will make this equal. Okay. And I'll show you how to find the a and b later. It'll be some number. But for now, all I want you to do is be able to factor the bottom into this and then separate it using the case 1 approach. So this is case 1. You have any questions before we go to case 2?
And just to double check our work, like we would just do FOIL on the denominator, correct?
Yeah, you can FOIL this out and you should get back here. You can check your work. That's true. Okay. Let's see here. Number 2. All right, so let's scroll down to case 2. We'll worry about the solving in a minute. To see how it says repeated linear factors, right? So we're going to decompose this denominator, or this fraction rather, using the partial fraction approach. That's what this whole section is about. It's partial fractions. Okay. So that's x cubed minus 2x squared plus x. So how would you guys factor this guy down here? What would you do first?
Factor out an x.
Yeah, they all have an x in common, which is the GCF. So whenever you're factoring, the first thing you do is check the GCF. This guy has one, so let's pull it out. So this will be x squared minus 2x plus 1. But now look at this guy. This looks like the previous type of problem. It's a trinomial where you can use trial and error. Yes, GCF is greatest common factor. So they all had at least an X in common, a factor in common. All right, so here do we do trial and error? So here we go. To be X times something times something, right? So factor this like we did before. So what are the factors of 1 that add up to a -2? That's what we did up here, this guy. 1 doesn't have very many factors, right? So
-1.
yeah, it's going to be -1 times -1 gives me a +1. And when I add -1 and -1, I get a -2. So those are the requirements to get the correct numbers in here. Okay. Once we have that, we'll do a case 2 approach. Okay. So this is called a repeated factor. So the way you would write it would be this way, right? Because the same thing times itself, be a square. Now, X and X minus 1 are distinct, but X minus 1 is repeated. You see that? So case 1 is kind of there in the background, but case 2 is going to have to deal with this repeated factor. So the first factor, just put an A on it. Who cares? But now we got to deal with this. Whenever you have anything to any power, you do it up until that power. So what I mean is you start with B, or whatever letter you're on, put X minus 1 plus C, and go to the next one, X minus 1 squared. Now, if it was cubed, you would go, if it was cubed, you would go all the way to 3. But since this is squared, you stop at 2. Okay. Does that make sense?
Yep.
So this is the new stuff right here. This line right here is the new thing we're learning. All this other stuff up here is from your algebra back in the day. Okay.
So on C, we're not actually squaring it. You're just using that to mark it, or we are squaring it?
This is technically being squared. The bottom part, yes.
How come B is like X minus 1 and C is the squared?
So that's the rule. You see how this is a repeated factor?
Uh-huh.
If this was a 3, right? Let's see. Here, let's change the problem for fun, right? I'll erase it in a minute. If this was a 3, then you would have to go 1, 2, 3.
Okay, gotcha. Thank you.
Okay. That's just how we do it. But since it's a 2, you would stop at 2. So I'm going to erase that. And then, of course, in a few minutes, we'll come back here and solve for A, B, C. Okay. But the thing I need you to learn today is what do you do when you have repeated factors, right? If it's different, well, it's just A and B. But if it's repeated, you got to go up to that number. Okay. Are there any questions on example 2? I need to get new pens. I haven't had a chance to pick them up yet. You guys have any questions on the algebra? Was that okay? All right, let's go to case 3 then. Case 3. Case 3 is called a distinct quadratic factors. So on this one, this happens when you can't factor it and it's stuck as a quadratic. So the case example 3 here. Decompose okay, x over x x squared plus x plus 1. No, I wrote that all stupid. I need to write that better. X minus 1 times x squared plus x plus 1. Now you cannot factor this. It's not going to happen. Okay. So we just got to decompose it the way it is. Okay. So what you would do is write a over the first one because that's just a linear distinct factor. No big deal. But since this is a quadratic factor, you will write bx plus c whenever that happens. And that's it. So this is what the scenario that you do this. Okay. Okay. Guess cool on 3? That's pretty straightforward, right? Decompose the next one.
I have a question.
Yeah, what's up?
This makes it case 3 because of how the numerator is. The 2x minus 3, the form it is, or how does that become case 3?
Well, this is you're talking about example 3, right?
Sure.
Okay, so example 3 is case 3 because you have a a factor down here that does not factor. It's a quadratic factor that is not reducible. No matter what you do, you can't factor. Like this one over here, you see how this guy was factored into linear factors, right? Here. And so we didn't have to deal with it. But when you are unable to factor it, meaning it's impossible to factor, then you do it this way. That's case 3.
And that's also known as irreducible.
Yeah, you can't reduce this or factor at all. I would say the best word would be just unfactorable. Prime is another word. It's considered to be prime.
But you can still solve it.
Yeah, this can still be solved, and we will do that later. Because remember, the goal, the reason we're doing all of this crap, right, is because we want to separate this fraction into 2 separate fractions, and we'll find the ABC ourselves, which we'll do later. Okay. And remember, this is just to remind you, we're not really doing pre-cal yet. This is just a separate side thing that we need to do. Okay. Now check this guy out. This one, it's like a glare right there, it's bugging me. Is the glare blinding you guys, or can you see through it? Yeah, okay. So on my end, it looks like I can't see anything, but.
No, it looks horrible.
Yeah, let me see if I can fix this.
Yeah, it is hard to see it.
Okay, give me a moment. There's like a lighter bright here.
That's a little better.
Oh, I see, here it is. There it is. Somebody must have reset my thingy. Thank you. Yeah, I was trying to avoid that stupid glare. I was like, this is not good. Okay, is that better?
I think so.
Okay, all right, so this guy in here cannot be factored, but it's also squared. So this is combining a repeated idea, like example 2, with example 3. So it's basically 2 and 3 at the same time. So remember we said when you have And power, you're gonna break it into 1 and then 2, right? Like we did up here. We went 1, 2. So same thing here. We're gonna do it for the first one, first power, ax plus b, because it's not factored, it's prime. I need to get another pen. So you put x squared plus 4 to the first power. Let me see if I have another pen here. Okay. So you're gonna have ax plus b over the first power. So x, man, stupid pens. X squared plus 4 plus, and then you do it again, cx plus d over the same thing, but to the second power. Okay. So it goes from 1 and then 2. Does that make sense? Just like we did up here. 1, 2. But because they are prime quadratic polynomials here, we got to do ax plus b, cx plus d, just like we did here. This is above a quadratic that was not factored, so I have to do this approach. Okay. And then you're gonna have to solve for a, b, c, d eventually. Is there any questions about this setup?
Could you repeat about what you have to do, what you had said earlier?
I'm sorry, one more time.
For example 3.
Okay, for example 3, we have 2 factors at the bottom, right?
Right.
That's gonna we're basically only looking at the denominator. That's gonna dictate how we set it up, okay? So the first one is a linear factor, so it's just an a over x minus 1, but this guy is prime and quadratic, so I have to do bx plus c. I have to add that x factor there, okay? So we did the similar thing here because x squared plus 4 cannot be factored. I have to add, but also it's repeated, so I have to do it twice. So ax plus b over the first one plus cx plus d to the second. So if this was 3, you would do it one more time. It'd be ex plus f.
And exactly why do the x's go next to the a and c?
Well, it needs to be here because it's kind of, the way to think about it basically is because it's kind of like it's going to reduce. So it needs to be like a linear factor here. But here, let me show you the definition. I think that'll be better. You guys can see the PDF, right? Okay, where is it? Here we go. So to each irreducible quadratic factor, ax squared bx plus c, occurring once in the denominator, the original fraction, there corresponds a single partial fraction in the form ax plus b. So it has to be done this way whenever you cannot factor this. So because it's quadratic, you need to have an x up here.
So
Okay.
it's basically just the setup.
Yeah, it is just a definition.
Oh, okay.
Yeah, there's no grand reason, but okay. So does the repeated idea make sense? The approach and the quadratic part. You guys okay? All right. Now let's do the Now the one that's difficult is going to be the next one. I don't like this one. And you'll see why. Okay. So case 5. So this happens when you have a improper fraction. So the question will be decompose
Oh, we can't see your paper.
oops. Is that better? Okay.
You need to
Decom-
change the view.
How does, oh, that's right. I'm on the PDF still. Thank you. Decompose the, here, where's that question? X cubed minus X plus 3 over X squared plus X minus 2. So you see how the power on the top, or the degree of the numerator, is higher than the denominator? So whenever this happens, you have to do case 5. So basically, you need to divide this and rewrite the question, and then start the decomposition. So you have to go back to your long division. You guys remember doing long division in algebra?
Yep.
Because you're gonna have to do it for these type. So whenever you see this degree higher,
Is there an easier way to solve it? I don't want to do all the work.
sometimes, sometimes the top, if the top is higher than the bottom, if you can factor it straight up, then you can avoid long division. But do you see an easy way to factor the top? I don't see one. Yeah, since we can't just like straight up and do it, we got to do it the hard way. But before we do that, let's review long division, because the pattern is important. Okay, I'll just make up some numbers here. 5 divided into 595, I guess. So the pattern, right? You go, you check how many times 5 goes into 5. You put the 1 there, and then you do 1 times 5, right? You guys remember this? And then you swap the sign. You subtract and start over. You bring down the 9 and you say, okay, well, 5 goes into 9 one time. 1 times 5, and then you swap the sign. Subtract. You bring down the 5. 5 into 45 9 times. 9 times 5 is 45. You swap the sign. All these steps need to be memorized when we start doing it with the algebra, because the algebra will be a lot more annoying. But it's going to be it is the same algorithm, same pattern. It's just not as easy, I guess. So let's go through it and refresh our memories. Okay, so which one's the divisor, first of all? Which one goes in the house?
The denominator?
Yeah, the denominator will be the divisor, right? And that goes into the x cubed minus x plus 3. Now, there's only one minor difference when you do this division, is you're only going to use this guy, this first one, to do all the dividing. So here we go. X squared goes into x cubed. How many times?
1.
Yeah, it kind of is. It's one x, right, technically. And if you're not sure, just do the work on the side, right? X cubed divided by x squared leaves you with an x, right?
Yep.
So you put that x up here. Now, what is the next step?
You gotta bring the x and the -2.
Right, we
Oh,
gonna-
we multiply that.
yeah, we multiply the x times everything, right? That's what the pattern says. So x cubed. Oh shoot, I forgot one step. Before we go any further, you see how there's a 3 and then there's no quadratic part? The rule says in the book that we should add a 0 term for the quadratic piece. That way we won't get confused. You don't have to, but if you don't do it, it throws everything off. So I'm going to put 0x² minus x plus 3. That way we won't mess it up. Okay, so x times x², x cubed, x times x is a positive x². X times -2 is a negative 2x. Now, what is the next step?
You have to subtract.
Yeah, I have to subtract all of them. So a good way to think about it is to put a giant parentheses and negative sign on everything, because all of these are going to swap signs.
Mhm.
Okay, so it's going to be, right, I'm going to write it over here. X cubed plus x², my scratch work over here. That's going to be negative x cubed minus x² plus 2x, right? All the signs will swap. That's what's going to happen here. So x cubed minus x cubed is 0, correct?
Mhm.
0 minus x² is negative x². Negative x minus a minus x is plus 2x, right?
That's
So it's
it.
negative x plus 2x.
Oh, yeah, x. That's x.
Then I'll just bring down that 3 just for the heck of it. Now, if that's confusing, what you can do is just swap the signs yourself and not worry about it. You could do it this way. Just remember, everything needs to switch to the opposite. Okay, so this is a plus, this is a minus, this is a minus. So x cubed minus x cubed, 0. 0 minus x² is negative x². Negative x plus 2x is x. And there's my 3. Who cares? Is there any questions on that first step? We basically did this first part here.
I'm sorry, can you write it? Because I was writing it the first way you did it and then you switched it. Now I'm a little confused.
Okay, yeah, sure. You want me to put it back?
Yeah, because I wasn't done writing.
Okay, let's put it back then. So picture a big negative on your result here. So the result was x cubed plus x² minus 2x. There you go. So that's how we have it. And if you distribute the negative, it's going to look like this. And that's what I wrote earlier when I erased it. Do you have any questions on how we got here to this?
So for any numbers that like you drop down, like that +3, anytime you drop down, those signs don't change,
You're talking about the 3?
right?
No, that one doesn't change. That one's just coming along for the ride.
Okay,
This like it's kind of like this one over here, right? Remember with the numbers? When you brought the 5 down, that one changed, right? But when you bring this 9 down, that does not change, correct? Because this 5 came from the multiplication. So when you multiply it and get a result, those are the ones that are going to switch. But like over here, when I brought the 5 down to make 45, that doesn't make it, it doesn't switch to negative, right?
right.
This is the same thing. All right, so next thing we do, now we start over, because that's the first step. X squared goes into negative x squared, how many times?
1.
Yeah, it's gonna be negative x squared over x squared, -1, right? So that goes up here. So -1 times all this will come out down here. So negative x squared minus x plus 2. So that's from multiplying the -1 on all 3 pieces, right? And then again, you're going to subtract it, so they're going to switch like they did earlier. Okay. So negative x squared minus x is going to be 0, right? That's going to be plus.
Mm-hmm.
I have a
Negative-
really, I'm so sorry. I have a really quick question. Why does the x squared go into the 0x squared -1 times? Or that?
No, it's
negative
going
one time?
to the,
Oh,
we're
it's x
dividing
squared.
into this one. Yeah. this
My
guy
apologies.
here.
Thank you.
All right, so x minus x is going to be x plus x, right?
Mm-hmm.
Because it's negative. So that result will be 2x. 3 minus 2, because this is negative, 3 minus 2 is 1. So now at this point, x squared is too big to go into 2x, right?
Mm-hmm.
So this is the remainder. We're done. So basically what we did is we said that this division, this original question, is going to be equal to the quotient plus the remainder over the divisor.
Oh, that's right. Yeah.
So this is the purpose. We're dividing this out, getting an answer plus a remainder. Okay, it's just that they're no longer numbers, right? That's the only difference. That's why it gets kind of difficult. But now that we're here, we can use the original question, right, was decompose, right? We haven't even started decomposing this. We're just doing division. You're going to decompose this guy. This guy we don't need to worry about. So we're going to need to use partial fractions on this term.
That's
Okay.
the remainder, right?
Yeah, the remainder part. Okay. So does this denominator factor?
I think so, yeah.
Oh, I see.
Let's see where we're going with this, right? This will be x minus 1, x plus 2, correct?
Mm-hmm.
So the decomposition would be a over x minus 1 plus b over x plus 2. So this is the actual question that they were asking, is the decomposition part. But to be able to do this, you first have to divide using long division. Okay. Is there any questions on the long division review or the remainder stuff or anything?
So what we're trying to do for the numerator is find the zeros?
For the numerator, you mean for the AB or which part?
For the first part.
You're talking about when we did the division, right?
Yes, yes, yes.
We are basically trying to reduce this improper fraction by doing division because the top part's bigger. So dividing this out gives you proper fractions. You see how this guy is bigger on the bottom, right? Versus the top.
Okay, I understand.
And then you can use any of the cases 1 through 4 once you've set it up. So case 5 is really just using long division to help you out. That's all it is. Okay.
Can you explain why on the long division part that, you know how we're using the X to factor everything in, and then you said the 2 on the bottom, that the X doesn't go into the 2X? Can you
Yeah,
explain why?
Yeah, this one here.
Yes.
It's because 2x is too small. See how before, when we first started, x cubed was bigger than x squared, right?
Right.
And then over here we did it again. X squared and x squared are the same size, so those divide. But here is too small. It's kind of like if you were to have like a small number here, and you can't do it, you would bring down a 0, right? You would add a 0, and then divide it. It's very similar.
Okay. Thank you.
But instead of adding zeros, we're just leaving it as a fraction. That's what we did. We're not going to do decimals since it's not a number. Okay, let's take a short break and then we'll go back through 1 through 5 and actually solve them, or at least the first few. Because after you see it a few times, you'll see it's the same thing. Okay, let's come back at about 7:10.
Sweet.
Take a break.